All right. So, as a philosopher, I think you'll really like this deep dive. It's it's a thought experiment.
Oh, yeah.
It's called the St. Petersburg paradox. It really makes you think about decisions
Decisions.
and rationality and how those two things work together.
Yeah.
So, imagine this, okay?
Okay.
There's a game. You flip a coin.
Okay.
It's a fair coin.
Mm-hmm.
You flip it until you get heads.
Okay.
The more flips it takes,
Mm-hmm.
the more money you win.
Okay.
So if you get heads on the first flip,
Yeah.
you get $2.
Okay.
If you get heads on the second flip,
Uh-huh.
you get $4.
Okay.
Third flip, $8.
All right. I see.
And so on.
Doubles each time.
Doubles each time.
All right.
So the question is,
Yeah.
how much would you pay
Okay.
as a rational person
Right.
to play this game?
Yeah, well, that's the heart of the paradox, right? Because when you first look at it, it seems pretty simple. But then when you start thinking about the math, you realize something's off.
Yeah, because the expected value,
Right.
you would think, would tell you how much you should pay.
Exactly. Expected value is usually a good guide for us, right? It tells us, on average,
On average,
what we can expect to gain or lose. So it seems like it should be pretty straightforward.
Yeah, so how would we calculate that?
So expected value, the way you calculate it is you take each possible outcome
Okay.
and you multiply the amount you could win by the probability of winning that amount. And then you add up all those products.
So for this game,
Mm-hmm.
we could get heads on the first flip.
Right. So there's a 1/2 chance of getting heads on that first flip. You win $2. So that's one part of the calculation.
1/2 times $2.
Right.
Okay, then a quarter chance.
A quarter chance of getting it on the second flip, winning $4, and so on. 1/8 chance of getting heads on the third flip, winning $8.
Oh, just forever. Okay. But if we keep doing that,
Yeah.
we're adding 1/2 times 2, which is 1.
Right.
A quarter times 4, which is 1.
Mm-hmm.
An eighth times 8, which is 1, and so on infinitely.
Exactly. And that's where things start to get a little strange.
The expected value is infinity.
It seems that way, right? The math tells us that a perfectly rational person, maybe even a philosopher like yourself,
Yeah.
should be willing to pay any amount.
Any finite amount.
Any finite amount to play, because in theory, the potential reward is infinitely large.
But I don't think so.
Yeah.
I don't think any rational person would pay $1 million
Right.
to play this game.
Your intuition is screaming, no way.
Yeah. I mean, the odds of actually getting to $1 million are astronomically small.
They are. So where did this paradox come from? Well, it comes from math.
Okay.
Back in 1713, a mathematician named Nicolas Bernoulli
Okay.
wrote a letter to another mathematician
Okay.
named Pierre Raymond de Montmort.
Okay.
And in the letter, he posed a problem similar to this.
He was already thinking about this in 1713.
Yeah, and it's kind of funny. Montmort, the guy who got the letter, he actually missed the real weirdness of the problem at first.
Oh, wow.
Didn't quite see the infinite series that was going on.
That's funny.
But later on,
Yeah.
Nicolas Bernoulli's cousin, Daniel Bernoulli, he came up with a really interesting solution in 1738, and he kind of shifted the focus away from just the pure math
Okay.
to how we actually value money.
Right. Because humans don't think with
Exactly.
these purely mathematical
They don't.
methods.
Right. His idea was that as you get more and more money,
Yeah.
each additional dollar is worth a little bit less to you.
Yeah, that makes sense. Like finding $1 on the street,
Yeah,
that would be awesome for me.
sure.
But for Elon Musk, who cares?
Right, exactly. It wouldn't even register.
Yeah.
And that's what's known as decreasing marginal utility.
Okay.
The idea that the value we place on each additional dollar kind of levels off as we get more and more.
Yeah.
Daniel Bernoulli used a logarithmic function
Okay.
to model this.
So does that solve the paradox?
Well, it helps. It's a brilliant insight,
Yeah.
and it definitely addresses the paradox to a certain degree.
Okay.
But like many things in philosophy, it's not that simple.
Right.
As we'll see, even Daniel Bernoulli's solution has its limitations.
Okay.
The paradox can kind of pop up again in different forms.
Okay.
And so we have to consider other ways of looking at it.
Interesting.
Yeah.
Okay.
So we'll get into that
Yeah.
a little bit later. So you could say, well, this is just a silly game. Nobody has infinite money.
Yeah.
So the bank can't actually pay those huge amounts.
Right. And who's going to sit around
Exactly.
and flip a coin
Yeah.
1,000,000 times?
Nobody has time for that.
Yeah.
But, we're not talking about
Exactly.
the practical
Yeah, it's a thought.
limitations here.
Experiment.
Right. It's a thought experiment. So what if we say, okay, maybe a central bank issues a blank check.
Okay.
They'll pay whatever the amount is.
Okay.
Or what if the payout isn't money? What if it's something else?
Okay.
Like pure happiness.
Okay.
Maybe some kind of experience machine.
Like a
Yeah.
utopia.
Yeah, like Nozick's experience machine, right?
Okay.
Gives you exactly the experience you want, tailored to you.
So the paradox still exists,
It still exists.
even when we take away all the practical limitations.
Right, and our intuition's still like, this is crazy.
Yeah.
So one idea that's been proposed is what's called a bounded utility function.
Okay.
And this is the idea that even if you get all this happiness or whatever it is,
Yeah.
there's a limit to how much you can actually experience.
Okay, so even for a philosopher,
Yeah, even a philosopher seeking truth,
there's a limit.
there might be a limit, right?
But isn't that just ignoring the paradox? Like, wouldn't a rational person say, no, I want the infinite
That's a great question.
utility?
Yeah, man, it kind of feels like we're cheating,
Yeah.
right? Like just putting a cap on things because it makes us uncomfortable.
Yeah.
But it's an idea that's out there.
Okay, are there other ideas?
There are other ideas.
Okay.
One of them is this idea of ignoring really, really small probabilities.
Okay.
This goes all the way back to the 1700s.
Okay.
And the argument is that when probabilities get so small,
Yeah.
it's rational to just ignore them.
So we're just going to pretend like those huge payouts don't exist?
Not exactly. It's more like saying there's a point where the probabilities are so tiny,
Yeah.
they don't really affect our decision.
Okay.
Think about it this way.
Okay.
A healthy 56-year-old man doesn't walk around terrified of dying,
Right.
even though there's a chance he could die today.
Right, but who gets to decide
Right.
where that cutoff is?
Yeah, and that's one of the problems with this idea.
Yeah.
It seems kind of arbitrary, like
Yeah.
who gets to pick where we draw that line.
Right.
But there are modern versions of this idea that try to make it a bit more rigorous.
Okay.
One of them is called rationally negligible probabilities,
Okay.
RNP.
RP.
And basically it says that for any decision, there's some tiny probability that's so small that a rational person doesn't have to worry about it.
But with the St. Petersburg game, those tiny probabilities could lead to infinite happiness. So why would we ignore that?
Yeah, that's a really good point. And, RNP might be permissible,
Okay.
but it might not be required. You know what I mean?
Right.
Like a rational person could still choose to consider those tiny probabilities.
Yeah.
So we're still kind of stuck with this tension between probability and value.
So what else can we do?
Well, instead of focusing on the absolute expected value, which can be infinite,
Yeah.
what if we compare the expected utility of different options?
Okay.
That's the idea behind relative expected utility theory.
Root.
Yeah, root.
Okay, so instead of saying, is this game worth an infinite amount?
Right.
We're saying, is this game better than that game, even if they're both infinite?
Exactly. So, like, imagine a version of the St. Petersburg game
Okay.
where you get all the winnings from the original game,
Yeah.
plus an extra dollar on every flip.
So it's definitely better.
It seems better, right?
Yeah.
But regular expected utility theory would say they're both worth infinity.
Right.
But root can say, well, this one's better,
Okay.
even though they're both infinitely good.
But I'm guessing there's a catch.
There's always a catch, right?
Yeah.
And there are some situations where REIT gives us undefined values.
Okay.
Like when the difference between two options is infinite.
Hmm.
So even root doesn't completely solve the problem.
So it seems like every time we think we've got a handle on this paradox, it slips away.
It does. But that's kind of the beauty of it, right? It keeps us thinking.
Right.
It challenges our assumptions about originality.
So are there any other
Yeah.
variations on this
Oh,
we
yeah.
should think about?
There's one called the Pasadena game.
Okay.
It's kind of a twist on the original.
Okay.
So you still flip a coin until it's heads.
Okay.
But in this one, you win.
Yeah.
If the first heads is on an odd-numbered flip.
Okay.
And you lose if it's on an even number flip.
Okay, so there's
Yeah.
a chance of actually losing now.
Right. So it's not just about how much you're willing to pay. It's also about
Right.
whether you're willing to risk losing.
So what's the expected value?
Well, this is where it gets weird.
Okay.
The expected value actually depends on how you add up the infinite series.
What?
Yeah, you can rearrange the terms
Yeah.
and get different results.
You kid.
Like you can get positive infinity,
Yeah.
negative infinity, all sorts of things.
So the expected value
Yeah.
is meaningless.
Well, it kind of makes you question the whole idea of expected value
Right.
as a guide for rational decisions.
Yeah, because if it depends on how
Yeah.
you add things up.
Right, like what order you do it in.
That seems crazy.
It is crazy.
Mathematically.
Yeah, mathematically it has to do with what's called a conditionally convergent series.
Okay.
But, we're not mathematicians, we're philosophers.
Right.
So for us, it's more about what this means for rationality.
What does it mean, rationality?
It shows us that expected value isn't always a perfect guide.
So are we just lost then? Like, is there no way to be
No,
rational?
I don't think that's it. I think
Okay.
it just means we have to be careful about
Okay.
how we use these tools.
Right.
Like expected value, we can't just blindly apply them.
Right. We have to think about
Yeah.
the context and the specific situation and all that.
Exactly.
So the St. Petersburg paradox
Yeah.
has really made us question a lot of things.
It has, hasn't it?
Yeah.
And, maybe that's a good thing. Maybe
Yeah.
that's what philosophy's all about.
Yeah. And for you listening out there,
Yeah.
keep thinking about these things.
Yeah.
Don't just take our word for it.
Question everything.
Go out there and explore these ideas for yourself.
Absolutely.
All right. Well, thanks for joining us on this deep dive.
It's been a pleasure.
And we'll see you next time.
Yeah, looking forward to it.